Hey, welcome back, chemistry students. I'm Mr. Silverstein. Today we're going to move into our last concept for this semester, and it's on covalent compounds. Now we've worked with ionic compounds, which was a metal and a nonmetal. Now we're going to move into working with compounds that are formed by nonmetals. You're going to pick this up in your unit pack on page 29. Let me share my screen. Let's get started. All right, so this is concept 3, naming covalent compounds. This will be part 1. And our objective is for you to be able to classify a compound as either ionic or covalent. And we're going to learn about how covalent compounds are formed. And this all falls under our big idea as to why and how elements form compounds in nature. So let's first go back and do a quick review of compounds and of ionic bonds, and then we'll move into the covalent bonds. Remember, elements naturally exist in compounds, and a compound is 2 or more chemically combined elements. Sometimes there's 2, sometimes there's 3, sometimes there's more. Sometimes there's an element and a polyatomic ion. And they form compounds to be more stable, so they can have an outer full energy level of electrons. And you need to have 8 for every element except hydrogen and helium. They only need 2. There are 2 main types of bonds. They're the ionic bonds. Those are the ones we've been working on so far. And now we're going to introduce you to the covalent bond. Remember, the ionic bond is a bond between a metal and a nonmetal, and the metal transfers electrons to the nonmetal. A covalent bond is between the nonmetals, and here electrons are shared. Covalent, sharing valent electrons. And remember, caring is sharing. So remember, an ionic compound is made up of charged ions. If the metal is positively charged, it's a cation. And it's positive because those metals can lose electrons. The anion, those are the negatively charged nonmetal ions. And they are negative because the nonmetals gain electrons during that bonding process. And although an ionic compound is made up of charged ions, the overall charge of the compound must be 0. So you add a group 1 metal with a group 17 nonmetal, and now they have a charge of 0. So let's move now into naming these covalent compounds. So let's talk about covalent compounds first. A covalent bond is a bond that results between non-metallic elements that share electrons. They can't give them up to each other, so what they do is they come in and they share them. A molecule is a compound that's formed when 2 or more elements are covalently bonded. And we're going to look at some examples of those. And these bonds can either be a single bond, a double bond, or a triple bond. We're going to show you how we note those when we look at the illustrations. A single bond is where 2 electrons are shared, 1 electron from each element. A double bond is when 4 electrons are shared. It's going to share 2 electrons from each element. And a triple bond is where 6 electrons are shared, 3 electrons from each element. So let's first look at the single bond. Here's where 2 electrons are shared, and when we do the illustration, it's shown as a dash. Now, let's take a look at H2. H2 is going to tell us we have 2 atoms of hydrogen bonded together. And so here we have our H with our single dot. You remember from the Lewis dot diagrams or the electron dot diagrams. And here we have our second hydrogen. And they're going to share an electron with each other. And that's going to form that bond. And it's represented by just showing two H's with a dash in between. And so when you look at that, you'll know you have H2. It's a single bond. Remember, hydrogen needs to have two electrons to be stable. And so here, H2 now becomes a stable molecule of hydrogen. Let's take a look at our most familiar water, H2O. Well, we're going to bond hydrogen and oxygen. Those are both nonmetals. So let's do our Lewis dot diagram for hydrogen. And you should be drawing these in your examples on page 29 in your notes pack. So we have our oxygen. It's got 1, 2, 3, 4, 5, 6 electrons, 6 valence electrons. It's going to need some more to become stable. Let's put our hydrogen and our hydrogen. And now these are going to start to share. We run a little circle around this and a little oval, and we're sharing these electrons with each other. Because remember, hydrogen can't give it up, so it has to share it. And then we're going to share this one. And so here we have a single bond. And it's shown, if we draw this illustration, oxygen has 2, 4 valence electrons. And we're going to use a dash between the oxygen and the hydrogen. And so we know these are single bonds. 2 electrons are shared. The electron from the hydrogen and the oxygen, and the electron from the hydrogen and the oxygen. Let's take a look at a double bond. Here, 4 electrons are shared, 2 pairs. So we have oxygen, our buddy oxygen. Oxygen has 6 valence electrons. We have another oxygen, 6 valence electrons, but now we're going to have to share to make sure that we have a full set. So we're going to share these 2. That's 1 pair. Then we're going to share these 2. That's the second pair. And we can illustrate it with the double dash representing the double bond. So I have 4 valence electrons, 4 valence electrons, plus 2 more, plus 2 more. And that's going to give us our 8 valence electrons around the outside of this molecule. Let's look at carbon dioxide. Well, looking at the formula here, we know we have 1 carbon and 2 oxygens. Well, let's put the carbon element out there with its Lewis dot diagram. It has 4 valence electrons. We put our oxygen out. Our oxygen has 6 valence electrons. Put our other oxygen out, 6 valence electrons, and now we're going to start to share. We're going to share these 2 electrons. We're going to share these 2 electrons. And now I have 8. And I have 8. Now we're going to share these 2 and these 2. And this makes a double bond because there are 2 pairs being shared. And we can illustrate it with this kind of illustration on the bottom here. We have our oxygen with 4 electrons, our oxygen with 4 electrons, and our carbon had 4 electrons as well. And we're going to share them out with a double bond. So each of these lines represents 2 shared electrons. 2, 4, 6, 8. That's a double bond. Now we're going to get really complicated. We're going to go into the triple bond, which is 6 electrons, 3 pairs are being shared. our buddy nitrogen. And here we're going to make nitrogen N2. It's a molecule of nitrogen. So we take out our nitrogen element, we do our Lewis dot diagram, 2, 4, 5 electrons. And we now take another one, 5 electrons. Well, we have to start to share these so we can end up with 3 pairs being shared. We're going to share these 2. We're going to share these 2. And then we're going to share these 2. And we represent this by 2, 4, 6 electrons being shared. And then these other 2. And now we have a triple bond of N2. And you can do this with any of the elements that are nonmetals. Let's take a look at our friend Tyler, and he's going to help us explain the ionic versus molecular bonds. Now, covalent bonds are also known as molecular bonds. So let's take a look at this. This video is also posted in your Google Classroom as a separate supplemental video. Take some personal notes, and then we'll get on to some practice.
In this video, we're going to look at compounds that are ionic versus compounds that are molecular, also known as covalent. We'll learn how you can tell them apart based on their formulas, and then we'll look at some important differences between them. So, how can you tell whether something is ionic or molecular? Well, it depends on the elements that make them up. So, ionic compounds are made of metals and nonmetals, whereas molecular, also known as covalent compounds, are made of only nonmetals. Let's do a couple practice problems to work on this. You will need a periodic table to do this. Here's the one that I'm using. I've left out a lot of the elements because they're not important. But what is important is this big, thick staircase that divides the periodic table into 2 parts. On this side of the staircase are the metals, and on this side of the staircase are the nonmetals. Okay, so here are a couple examples. The first one, sulfur dioxide. So what are the elements it's made of? It's made of sulfur and oxygen. Both of these are nonmetals, which means that sulfur dioxide, SO2, is a molecular compound. Sodium chloride is made of sodium, a metal, and chlorine or chloride, which is a nonmetal. So sodium chloride is an ionic compound. All right, now H2O is made of hydrogen and oxygen. Now you might think that hydrogen is a metal because it's on this side of the periodic table. It's fine, it's understandable if you do that. But hydrogen is an exception. Even though it's on this side of the periodic table, it's actually a nonmetal. It's the only exception. So hydrogen and oxygen are actually both nonmetals, which means that H2O, water, is a molecular or covalent compound. Okay, copper 2 fluoride. Copper is here, fluorine or fluoride is here, metal, nonmetal, so this thing is ionic. Okay, let's look at a few trickier examples. So far, we've only looked at compounds that have 2 elements in them, but there are a lot of compounds out there that have more than 2 elements in them, okay? So propanol, for example, is made of carbon, hydrogen, and oxygen. All 3 of these are nonmetals, though, so this is still a molecular or covalent compound, even though it has a bunch of nonmetals. Okay, don't be confused by that. Here's another example. Lithium nitrate has lithium, which is a metal, but then it also has nitrogen and oxygen, which are both nonmetals. So it's still got the metal, non-metal thing going on. So it's an ionic compound, even though it has 2 nonmetals. And the same thing is true of sodium sulfate. It's got sodium, a metal, and 2 nonmetals, sulfur and oxygen. But metal, non-metal means it's ionic. Now, lithium nitrate and sodium sulfate are actually special kinds of ionic compounds because they have 2 different nonmetals. They are what are called polyatomic ionic compounds. If you want to learn more about these, I've got videos on them. So now we can look at a chemical formula and we can sort them and we can decide whether something is ionic or whether it's molecular or covalent. So what? Who cares? Well, there are some very important differences between ionic compounds and molecular compounds. Let's take a look at some of those right now. So one really important difference is how the atoms in these compounds are held together. In molecular or covalent compounds, the atoms that make them up are held together because they're sharing electrons. Here's what I mean. Water, H2O, is a very common molecular compound. It's made of one oxygen and two hydrogens, and these lines between the atoms show that they're connected, and they mean that they're connected because they're sharing electrons. Here's how I like to think about this. It's like oxygen and hydrogen both have these little hands, and the hands are joined together. It's like they're holding hands, and they're holding hands because they both are trying to hold on to a pair of electrons, which I've drawn here in red. So we've got oxygen and hydrogen connected together because they're holding on and sharing these electrons here. That's what makes the atoms connect and stick together in a molecular covalent compound. Okay. Now, on the other hand, in ionic compounds, the atoms aren't being so nice to each other. Okay, they're not sharing. The atoms stick together in an ionic compound because one atom steals another atom's electrons. So electrons get stolen, and then opposite charges attract. Let me show you what I mean. So sodium chloride, or NaCl, is a very common ionic compound. It's made of sodium and chlorine, and here they are, just hanging there. Now, for these two guys to stick together, here is what happens. First thing that happens is chlorine reaches its greedy hand over and grabs an electron from sodium, okay, and it pulls it back. So now chlorine has an extra electron, and sodium has lost one of its electrons. This causes chlorine to now get a negative charge because it has a new electron, and sodium, because it's had one of its electrons stolen, now it has positive charge. So now we have a positively charged ion here and another negatively charged ion. What do opposite charged things like to do? They like to come together. They stick together. They're attracted to each other just like magnets. So now we have a positively charged thing and a negatively charged thing. These arrows show how they're going to come together. And we end up with the two atoms stuck together because they're oppositely charged. And that's what holds ionic compounds together. So covalent or molecular compounds, the atoms are stuck together because they're sharing electrons with each other. Ionic compounds, the atoms are stuck together because one has stolen the other's electrons. It's given them opposite charges, and then those opposite charges have, let me try that again. And then those opposite charges, there we go, have attracted just like that. So this is one way that ionic and molecular compounds differ. Here is one more. So another big difference is how these compounds would actually look if we could see the atoms that make them up. So molecular or covalent compounds are made of molecules, which is a fancy word for a bunch of atoms that are stuck together in a clump. Here's what I mean. So sugar is a very common type of covalent compound, and it is made of molecules where I have these atoms here stuck together in a clump, 2 carbons, 4 hydrogens, and 2 oxygens. So a grain of sugar would look like this. It would look like a number of different sugar molecules that have all kind of come together and formed a clump here. Okay, but the big deal here is that these molecules are individual clumps of atoms that then come together to make stuff. On the other hand, ionic compounds, they're not made of clumps of atoms like molecules. They're made of what we call lattice structures. And here's what lattice structures are. The example I'm going to give you is salt, which is sodium chloride, table salt. And the lattice structures of sodium chloride look like this. Look how different this is from the molecules that make up sugar. You just have the sodium and the chloride atoms stuck together in this sort of very organized box-like shape. This is what a lattice structure is. There aren't individual clumps of sodium chloride the way there are individual clumps of sugar. Instead, all the atoms are stuck together in this very regular shape. Now, one big important difference between covalent molecular stuff and ionics is what happens when they dissolve in water. These guys just come apart into molecules, whereas the individual atoms come apart when an ionic compound dissolves in water. But we're getting a little ahead of ourselves. If you're interested in other differences, check check out videos that I have on physical properties as well as what happens when you dissolve ionic molecular compounds. In this video, we're going to look at.
All right. So remember, on the covalent bonds or molecular bonds, they are sharing electron pairs between the atoms. And just like Tyler talked about, they're reaching over and they're sharing with themselves. The covalent bonds occur between nonmetal elements only. And these electron pairs are known as shared pairs or bonding pairs. And the sharing of electrons allows the nonmetals to bond and become stable, forming molecular compounds. And you can always identify a covalent bond or molecular bond by just looking at the elements and seeing, are they nonmetals? If they're nonmetals, then they're going to be a covalent or a molecular bond. If there's a metal and a nonmetal, that's an ionic bond. And we spent a lot of time on ionic bonds. All right, update your notes. Go back and look at these slides. Make sure you have this information down. Single bond, 1 pair. Double bond, 2 pairs. Triple bond, 3 pairs of electrons are being shared. Then, open up assignment L2. Take your time. You're going to need your periodic table and practice the covalent bonds intro recap. Once you're done with that, open up L3 and we'll get into part 2 of covalent bonds. I'm going to stop my share right now. Stop my share. All right, well, I'm Mr. Silverstein. That's all we have for you on this lesson. If you have any questions or comments, email me or send a private message through Google Classroom. We'll get back to you quickly. You guys have a great day.